Very good morning to everyone. Today we are going to see the gears, kinematics of gears and gear trains. Gear mechanism, simply called gears, consists of two gears. Without two gears we not able to transmit the power from one shaft to another one shaft. If we have only one gear means it is not able to use to transmit the power from one shaft to another one shaft. So to utilizing the two gears only we can able to transmit the power from one shaft to another one shaft. So it is called gear or gear mechanism. Combination of gear mechanism we can utilizing to transmit the distance places. It is called gear trains. Simply a gear is called as toothed wheel. In the outer periphery of a cylindrical portion it consists of some tooth is called gears, which is used to transmitting the motion and power from one shaft to another one shaft. It can able to transmit the rotary motion in both the direction. That means driver and driven both are in the same direction, as well as opposite direction also possible by using a idle gear. Also it produces the constant velocity ratio for the desired output. Advantages of the gear train: it consists of there is no slip in the gear drives, and it will transmit the exact velocity ratio. Large power can be transmit compared to the belt drive or chain drive. Its efficiency is up to 99%. It can able to transmit the very less space. For example, in the clocks, in watches, very near places we can able to transmit the power from one shaft to another one shaft. There is some disadvantages also. It consists of need special machines and tools for manufacturing the gears. Then high maintenance cost, chances of vibration and noise during the operation. It requires precise alignment of shaft for power transmission. Types of gears. The gears can be classified based on relative position of two shaft carrying gears: parallel axis gears, intersecting axis gears, non-parallel and non-intersecting axis gears. Then other categories classification based on the types of meshing of gears. The type of meshing is classified into two categories. First one is the internal gears, and next one is the external gear. In the internal gear mechanism, one gear will be the external, the another one will be a internal gear. So the external gear will be smaller, the internal gear will be bigger. This is bull gear. The external gear in the combination of internal gear mechanism, it is a pinion. Then external gear classification, it consists of both are the external gear tooth profile. Coming under the category of parallel axis gears, it is classified into spur gear, helical gear, herringbone gear, and rack and pinion gear. Actually the rack and pinion gear is the basic concept for generation of all the gears. So rack is a linear, a flat surface. Over the flat surface we get cut the gear tooth. Then it is combined with the pinion, a small gear. So using that we can able to transmit the rotary motion into reciprocating motion, as well as rotary motion into reciprocating motion. Both the motions also can be converted. Next, spur gear is the tooth is parallel to the axis of the shaft, so it is called as spur gear. So spur gear will be mixed with the another one spur gear only. The next one is the helical gear. The helical gear, it having some inclination. The tooth profile will be some inclination with the axis of the shaft. Here also the same helix angle gear will be engaged with the same helical axis and module. Helical gear cannot able to mess with the spur gear will not be able to mess with the helical gear. herringbone gears. These gears are combination of two helical gears with each other is called herringbone gears. So two sides of the gear will be different angles. The same angle gear will be meshed with another one. The next category is intersecting axis gears. So intersecting gears under the category of bevel gears. In the conical surface we can cut the gear tooth, means it is called a bevel gear. It is classified into two categories. One is the straight bevel, then next one is the spiral bevel gear. The straight bevel gear will be parallel to the axis. The straightness of the teeth is parallel to the axis of the shaft is called straight bevel gear. The spiral bevel gear is it having some inclination of the tooth profile with the axis of the shaft. So straight bevel gear will be parallel with the mesh with the straight bevel gear one, another straight bevel gear only, as well as spiral bevel gear also mesh with another one spiral bevel gear only. The non-parallel and non-intersecting axis of gears. The other name for that one is Q axis gears. It is under the classification it is hypoid gears, worm and worm mill, then spiral gears. In these gears which is used to great reduction speed ratio between the input and output shaft. Then other gear mechanism also we can use to reduce the speed ratio, but comparatively the other classification, the worm and worm wheel, which is used to more speed reduction. But another one difference of this non-parallel non-intersecting gears are only the worm will be the input and the worm wheel is become act as a output gear. We not able to transmit the power from worm wheel to worm, so it can able to transmit the power and rotation in one direction only. The gear tooth profile consists of two types. One is the cycloidal gear tooth profile, then next one is the involute tooth profile. The cross section of the tooth consists of tooth profile. It is the segment of the cycloidal curve, means it is called as also cycloid profile. So the profile of the cycloid motion, so it consists of two portions. One is the epicycloid, then another one is the hypocycloid. Because of from the pitch line of the gear profile, above the pitch line it is like as epicycloidal gear curve. Then below the pitch line circle it is a hypocycloid curve. So using that we can able to create the gear tooth profile. It is cycloidal profile. So it is combination of hypocycloid and epicycloid. The next category is involute gear tooth profile. So involute we know very well. So the tracing of point of a chord, end of the chord, as the chord is unwound from a cylindrical called the base circle. So when we unwound a chord from a rolled cylinder, the end of the point of the thread tracing some path, the path is called as involute. The segment of the tooth will be as like involute profile, means it is called involute tooth profile. So most of the cases we are utilizing the involute tooth profile only. Special case only we are utilizing the cycloidal tooth profile. Next we are going to discuss about the nomenclature of the gear. The nomenclature of gear means we are taking a one tooth profile. From this tooth there will be an pitch circle. Pitch circle is called as diameter. Every gears will be defined by using the pitch circle. The pitch circle will be equal to mt. That means m is the module of the gear into t is the number of teeth. So based on that only we can calculate the pitch circle. So above the pitch circle the part of the gear is called addendum. Below the pitch circle the part is called as dedendum. So tip of the tooth as an imaginary circle we have to draw for a gear, it is called addendum circle. The root, the bottom portion of the root of the gear teeth, we can draw a imaginary circle, means the circle is called as addendum circle. While two gears are engaged, there will be some clearance between the root of the gear and the tip of the gear. That clearance is called as clearance. The addendum value will be the 1 module of the gear. The addendum value will be the 1.25 module of the gear. Then the clearance will be 0.25 module of the gear. So every corner of the gear tooth having some fillet will be there. That fillet radius also 0.25 module for that one. The next one is the space width or gear tooth thickness. Space width, otherwise the gear tooth thickness. The pitch, next one is the pitch. Pitch means when the distance between the one tooth to another one tooth for the corresponding distance. For example, choosing the midpoint of a one tooth means the starting distance from midpoint of the tooth to the another one tooth midpoint. This distance is called as pitch. The length of the tooth is called as face width. The top portion of the tooth is called as land. The side portion of the addendum of the gear tooth is called as face. The bottom portion of the addendum will be called as flank. The corner portion is called as fillet. Fillet is 0.25 radius, 0.25 module of the radius. So thickness of the tooth is called as face width. Gear trains more than two gear shaft we are utilizing to transmit the power, means it is called as gear trains, which is used to transmit long distance as well as great reduction of speed. We can utilizing the gear trains. Type of gear trains. The gear trains can be classified into single gear trains, compound gear trains, and planetary gear trains. Mostly the simple gear train is transmit from one shaft to another one shaft, which is called a simple gear train. It will consist of only small reduction of the velocity ratio as well as torque reduction. This figure shows the simple gear trains. So one gear is joined with another one gear, then another gear is connected, then another gear. So likewise we can combine the gears, which is called as simple gear trains. In compound gear train, parallel of number of shaft using to transmit the power. So every shaft carrying two gears, input shaft and output shaft carrying one gears only. Intermediate shaft carrying two or more gears, which is used to transmit the power, means which is called as compound gears. Then planetary gears. Other name for the planetary gear is epicyclic gear trains. The gear rotating themselves also rotating another gear is called as planetary gear. It consists of the three gears. One is the sun gear. It is a smaller gear. It is mounted at center point of the gear train. Then planetary gear, around the sun gear we have kept 3 or 4 planetary gears. Depends upon the requirement. 3, 2, 4 we can utilizing. These 3 planetary gears are mounted inside a ring gear. So beyond that one there will be a carriage will be there. So using that carriage we can fixing any one of the gear, sun or planetary or carriage, otherwise the ring gear, any one of the gear, we get the input and output motion. So planetary gear having great reduction of speed comparing to the other gear trains. So most of the gearboxes, for the industrial gearboxes, we have utilizing the planetary gears. So the planetary gears having sun gear will be normally connected with the input of the shaft. Then from the sun gear to planetary gears are connected. The 3 planetary gears are combinedly connected with the planetary carrier. Then also these planet gears are mounted inside a ring gear. So while sun gear is rotating, the planetary gears also rotate Due to the rotation, the ring gear normally fixed. So what will be happen? The plant gears rotate themselves as well as revolve inside the plant ring gear. So automatically the carrier will be rotates. From the center of the carrier we can mount with output shaft, so we can get the output motion. So this is called planetary gears. So the planetary gears having high gear ratio reduction, then for it is used for automobile power transmission, as well as we can use it in bicycle for controlling the speed of pedaling automatically by manually. Also used for powertrains between internal combustion engine and electrical motor. Thank you.